Hello everyone, welcome to my channel. I am Aryavardhan Sharma and today I am bringing you the project of autonomous car using artificial intelligence. I've created this simulation of the autonomous cars and credit goes to the Audacity car simulator. The simulator is created based on Unity and this project is a part of my subject called artificial intelligence is currently coming in my degree ICT semester 6 and I'm pursuing my bachelor's of technology at Marwadi University in the field of information and communication technology. So let me move on with the project and explain you what I have done and how the things have been there. So first let me show you the Audacity simulator which we require for collecting the dataset and creating the dataset. So this is actually the self-driving car Audacity simulator. So once we go into training mode, this is the Audacity simulator and this has been created in Unity, the whole map. Using your WASD key, you will be able to drive around in this environment and how to create the dataset. So once you click on record, it will start recording. I'm not actually clicking it right now because I have already created the dataset. I'll show you. So what you need to do is you need to drive around in this environment around 4 to 5 laps I would say will be enough. So once you start clicking the recording button, then it will ask you for a path. You need to select your path where you want to store. I have already done it, so I won't do it again. Once you have done it, then what you need to do is you need to drive this car in this environment for around 4 to 5 laps clockwise and anti-clockwise as well. Now, why to drive the car anti-clockwise? That's because if you are driving the car only in one direction, then the model will get biased towards driving on that side particularly, which we do not want. We want that the model should be able to drive in the lane that we desire, that is on the left lane, and or if we are returning, then on the right lane as well. So, based on that, we need to drive the vehicle in the environment 4 to 5 laps clockwise and then 4 to 5 laps anti-clockwise as well. I have installed three cameras on this car in the front, which are taking pictures of the whole environment from three different angles, that is left, center, and right. So now I'll show you the demo. I'll show you the dataset. Now, if you will be able to see, there are center named images which are from center, which are taken by the center camera. If we scroll down, then you will start seeing the left images. So these are the images taken by the left camera. And if you scroll down more below, then you will see the right images as well, which are taken by the right hand side camera. So these are the three different angles that I have taken in order to create my dataset. After creating the dataset, I have written this script, Python script, in order to train the model. So I'm using TensorFlow to create my CNN model. So these are all the libraries I have created. I have loaded my dataset and then I have removed the center, left, and right wordings. I don't require the whole path of the images. I have just removed it. Now, whenever you are going to train the model, it is necessary that you first look at the nature of the dataset. If it is not normalized, you need to normalize the dataset in order to get good performance. So here, as you can see, there are more of zeros. So I needed to cut it. So I have set a threshold of 400 and I'm going to cut all the zeros above that. So as you can see, the total data is 405 cross 7. And now the removed data is around 25,000. These are the data points that are removed. These are the remaining data points. And now this is how the graph looks. So the range of the plotting is reduced 0 to 400. Before it was 0 to 3000. Once the data has been balanced, so now I have created the test and training split. This is the image steering. So how it is going to actually identify which from which angle the peak has been clicked. So that's for that. And this is just the database dataset details. After that, we come up on the training when validation test split. So I've used sklearn library to split the whole data set. Once we do that, these are the uh, details of the data set of the training set and validation set as well. So as you can see, it is almost equally distributed. These are the image augmentation techniques to diversify our data set because we are having less images, and to train the CNN network we require huge amount of images, large data set. But as we are having less images, so what I am currently doing is I am just using image augmentation techniques in order to diversify the data set. So the first thing that I am using is the zoomed image. To remove this, as you can see, this is the bonnet of the car which should not come. So this is the image clicked from the right side of the car, and in this you can see that it almost has been removed. This is the pan method, the image augmentation techniques, in which we will remove certain borders from the images. So as you can see, this is the black border that has been added. So a part of the image has been removed. This is another image in which we are fluctuating the brightness. We are actually reducing the brightness of the image. This is the flipping technique in which we will flip the image. So this is just to randomly, what it will do is it will randomly pick images from the dataset and pick a random augmentation technique and perform it to bring the diversity in the dataset. Yep, and these are the augmented images, various images. So it just shows how I brought the diversity in all the images. After that, I am using the pre-processing because the CNN network works well with YUV screen color scheme. So I'm just converting all my RGB images into YUV. And this is, as you can see, the YUV image. Then I have written a batch generator script which will generate my image batches. I have written the training script as well. So here I have actually read a newspaper of the NVIDIA, which has an end-to-end driving architecture, driving car autonomous car architecture. So I have taken the reference of that model, and I have performed few hyperparameters tuned, fine-tuned the model. Have some different layers because their data set is huge compared to mine data set, of course. So I have done those few things that I needed to, like changing the image sizes, like changing the parameters of the layers, changing the layers. I have commented out few layers because there was no requirement for it. This is the whole layer summary that you will get. This is my whole model. So as you can see, these are the trainable parameters, and as I said that I have used TensorFlow for training purposes, and at the end I have gotten 0.05% loss, and validation loss is 0.02, which is quite a good number. This is the epoch versus loss chart for training and validation. So yeah, so that was about it. So now coming to the drive.py file. So I've actually created a backend because I required to uh, connect my, we can say, the script of Python as well as the script of uh, as well as the Audacity simulator. So what I've done is the dataset is having images. With that, it is having the steering angle, throttle, and braking and speed. So these are the four parameters that I have taken for my dataset. And with each microsecond the image gets clicked, the parameters also get stored. Now based on that, I have trained my CNN model. So let me just quickly explain this backend. So it is doing nothing else. It is creating a web socket, and it will fetch the image from there, give it to the model, run the inferences, the model will make the predictions. Based on that predictions, the commands will be given. That commands will be given to Audacity simulator through the WebSocket only, and then the simulation will be performed in the simulator itself. So let me just quickly run this simulation and show you the output. Model loaded successfully. Good, good. Yeah, so as you can see, my hands are right here and the car is being driven. So on the left hand side, you can see the parameters are getting printed. So this is nothing but the first reading that you can have is the steering angle. The second is the amount of throttle we need to give to the car to for acceleration. And the third parameter is the speed. So as you can see, the car is being automatically driven on the track, and this is just a part of the whole autonomous system, autonomous drive ADAS system that is installed in cars, that is autonomous driving assistance system. And we'll be further extending this project by integrating various sensors like lidar, monolithic cameras. Yeah. So thank you guys. If you have any further doubts or queries, then feel free to ask me. I have included the GitHub repo link in the description. Thank you.